Okay, hi. We are Hanna and Herman. That sounded like a pop band name. So we work in the Vir team in RHEL, and one of the main work that we do there is to maintain virtuofsd. Basically, we want to talk about the line migration state. That is one of the most complex and larger features that we are working on. The qubit integration, and then we will talk a little bit about the performance, some of the issues that we found, and some futures improvement, a new experiment that we are doing for the future. So as I said before, the line migration is one of the largest and most complex features that we are working for almost 2 years now. So currently in Upstream and also in CentOS 9 and Fedora, we support like a basic path-based migration. The good thing is it doesn't require any privilege, but and it's good enough if you have to share like a read-only file system, even if you share with other VMs, or if that file system is exclusively accessed by one single virtuofsd instance. And also we are working to support like a more robust file handle-based migration mode. The bad thing is that requires some privileges, basically be root. And all this work that about the line migration, we started working on this because basically QVIR, the idea to share some resources to the VMs and be able to migrate the VM. Currently, if you are using virtio-fs in a VM, in QVIR, you cannot migrate. But we found out that also OpenStack will take advantage of the line migration capabilities of virtuofsd. So the current situation with QVIR, this is like a very schematic, simple architecture of how is a node in QVIR. We have like two namespaces, Kubernetes namespaces. It's not related with the Linux namespaces. I hate that everything is called namespaces, but yeah. So currently we have the pod when QEMU runs in its own container that is called the compute container, and virtuofsd is run in its own container in the same pod. If you want to share config maps, secrets, service accounts, and our API, from the people that is not familiar with that is some Kubernetes resources that are exposed to the container as a file system or as a directory with files inside. So it's very normal to use virtuofsd to share that file system, that directory with the VM. The current situation is for this type of resources, virtuofsd runs unprivileged, and the idea is to use the current path-based line migration to do the migration base. Because these resources are read-only for the point of view of virtuofsd. Of course, that can be changed if you update the config maps in the etcd database of Kubernetes, but it changed in a very expected way, let's say. But if you want to share PVCs, let's assume that the PVC is like a shared directory using NFS or any other type of network file system. That's easy to see. The current situation is virtuofsd runs as a privileged component, as a privileged container in the same pod that QEMU. And there is kind of problematic. One is the guest can create root-owned files in that PVC, and that's especially problematic if you mix VMs with normal containers workloads in Kubernetes, in OpenShift. And also in the near future, it's a thing that I think is working from a year now, Kubernetes will forbid privileged containers for the users. You still can have privileged containers in the infrastructure part, like for example, the QVIR handler is part of the infrastructure of QVIR, but not in the main namespace or any user namespace. I mean the user that use the cluster, no, Linux user namespace. So how can we fix that? Can we make virtuofsd non-privileged also for PVCs? Well, yeah, but the problem is it's very rare that one VM wants to have like exclusive access of a shared network file system. That is possible. But the problem is usually the use case is we want to have multiple VMs accessing the same shared file system. So we don't have exclusive access. And also that means that the one VM, while doing migration, other VM can start moving and changing those shared files, like for example, removing it or renaming it. So our current mode that doesn't require any privilege, that is path-based, is not robust enough for all the corner cases that we can have. Especially that, for example, we are migrating, we collect all the paths, and then another VM change those path names to other things. So in the target, in the destination, we cannot find those renamed files. We talk about this in more detail in our last KVM forum talk. So the link is over there. So basically, we need file handles. But file handles require privileges. So how can we fix that? We cannot make virtuofsd privilege again. So we need to keep virtuofsd as unprivileged inside the pod. So the idea is we are working with Alice, that is someplace, from the Kubernetes team that also work in the Vir team in Red Hat, to implement like a privileged component that will be part of the Kubernetes infrastructure. So it will not be in the main namespace, it will be in the Kubernetes namespace that is allowed to have some privileges. This privileged component will be completely stateless, so nothing, there is no state that needs to be migrated, so the migration will continue working. And it will use the seccomp notifier. The seccomp notifier is like an extension of seccomp. Seccomp is like a very generic framework to intercept syscalls, but instead of just simply allow it or forbid that syscall, we have like a user space component, a user space process that usually is more privileged than the one that is monitored. And we can make that privileged component run that syscalls on behalf of the less privileged component. So the idea is when virtuofsd tries to use one of the syscalls that is related with file handles, instead of virtuofsd that all the work, the privileged component will be notified that, hey, this process wants to run this syscall. We will check that that syscall is safe to call, and they will do the calling on behalf of virtuofsd. And then we will return like a signet file handle just to prevent any forgery to the unprivileged virtuofsd. So for the point of view, virtuofsd will work like if he has the privilege enough to work with file handles. This privilege component also in the future can be extended to support also EC Linux and POSIX ACLs, because the extended attributes that are required for EC Linux and POSIX ACLs require also privileges and cannot be namespaced, I mean in the Unix namespace sense. So I think that this could be like a general solution. We think that is the simplest one, even if it doesn't look like. But from the point of view of virtuofsd, it's simple. virtuofsd doesn't require to be changed, and is the part that requires less changes in KubeVirt. And also, since it's a stateless, that will be like a daemon set. If the privilege component dies, will be automatically restarted. So I think it's that the best of both worlds. Okay, this is my part, and now Hanna.
Thank you. Let's talk about performance. So to get a general idea of where we stand with virtiofs, I wanted to compare it to virtio-block. The configuration is that I run FIO as a benchmarking tool on a single file in a file system in a guest. One case virtiofs, the other case simple file system on a virtio-block disk. And in each of these cases, I have three different configurations, the first of which is going to use the host page cache to access the backing data on the host. In the second case, we're bypassing the host page cache. In the third case, we don't have any backing data on the host whatsoever, so we have a null configuration. We just immediately reply to every request from the guest as soon as possible, just as Kevin said, to get a look at how fast the interface itself is, basically. these are the results in operations per second. Let's go through each of the configurations one by one. First of all, we have the host page cache case, which is generally the configuration you're probably going to use with virtio-fs. And to my surprise, virtio-fs actually performs just as well as virtio-block, basically. I thought it would perform much worse. So it is a welcome surprise, but it's also very boring for this talk. So let's go next to the next case, which is the ODirect case, where we bypass the host page cache. The virtio-fs luckily performs terrible, so I have something to say. I assume that is, or I'm pretty sure that is, because virtio-fs uses completely synchronous I/O internally, so it awaits every single request completely until it fetches the next request from the virt queue. And so the longer the requests take, which happens to be the case with ODirect, the worse it gets. So to fix the performance in this case, we would need to implement proper asynchronous I/O, just like QEMU does it for virtio-block. And in the opposite end of the spectrum, we have the null configuration where we don't await any requests on the host whatsoever. And the first thing you'll probably notice is that there is a big gap for virtio-block between the sequential and the random read case. Now, this is not a virtio-block talk, so I don't need to explore why that is, and can directly focus on virtiofsd. And I'm just basically assuming that the 470K I/O performance for virtio-block is the one to measure against, and you can see that there would be some room for improvement for virtiofsd in that case. Now, the question is that because of our implementation or because of the interface? And to try to answer this question, I wrote a minimal implementation of virtio-fs just to compare how fast that could be. These are the results. The first two for virtio-block and virtiofsd are from the previous slide. And now with the minimal example added to it. And you can see, well, performance is basically just as good as virtio-block. So I would assume that the interface itself is fine. It makes also sense because, like, structurally wise, it is very similar to virtio-block. However, it does mean that virtiofsd has some room for improvement there, so we should really investigate why it doesn't perform as well as this minimal example where we can improve things. Besides that, as I said, we also need to implement proper asynchronous I/O handling for all the cases where you want to bypass the host cache, especially. And then there are some cases where that I did not talk about. So first of all, depending on your workload, you may not be that interested in single file I/O performance, but instead more about general file system performance. Like creating files, listing directory contents, and stuff like that. I didn't gather any data on that, so I can't say anything about this in good faith, so I won't. And leave this to another talk, I suppose. The second case is that when you're trying to use I/O during in the gas for these benchmarks to find performance really suffers. I assume that is because Fuse is trying to use the poll operation, but we don't implement that. I think to implement that properly, we would also need asynchronous I/O support in virtiofsd. So basically, these two things would then come together, and then we would see whether that improves performance. Finally, the virtio-fs kernel driver supports multiqueue as of this year, but virtiofsd does not yet. It seems really simple to implement because we already have multi-threading support basically in virtiofsd. And Rust VMM also makes this really simple. And when I implement this in the very minimal example, I found a 90% improvement for 4Q. So this is also really promising. We just need to do it basically. Moving from quantity to quality, what can we do with virtiofsd beyond what we currently do? The question might be strange, but let's look at what virtio-fs is to understand why I'm asking it. virtio-fs is basically just the Fuse protocol transported over virtio, right? Nothing more. So when you're mounting a virtio-fs file system in the guest, what you're really doing is mount just a Fuse file system. Now, for your Fuse file system, it's served by the Fuse kernel driver, which connects to some Fuse driver running in user space usually. And in our case, this Fuse driver is in virtiofsd, so it's running on the host on a different system. Doesn't really matter. But to communicate, both use the normal Fuse protocol like any other Fuse driver would, except they're communicating through a virtio-fs device, so through virt queues. Now, the first fun thing we can do is to drop that virtio-fs device. So because we just have a normal Fuse driver in virtio-fs, we can just have it connect to the dev Fuse character device like any other Fuse driver would do, and thereby mount the virtio-fs file system, the virtiofsd served file system, on the same host that virtiofsd is running on. Now that's really, really boring because virtiofsd ideally is just a pass-through file system. So this would just be a glorified bind mount. But it does raise one interesting question, namely, you can see that for Fuse now we have two different transports, right? So we have either this transport, the normal, the legacy transport basically, where you connect to a character device to send Fuse operations through, or you can have the virtio transport, where you transport these operations through virtqueues. And the question you might ask, and that certainly Eugenio asked, was which is faster? Kevin already showed a Fuse benchmark. This is another one. So when you write a minimal Fuse, or when I wrote a minimal Fuse server, just to see how fast the dev Fuse character device can perform, I found it's actually not that bad. Can get quite high I/O ops by itself, but actually not as high as virtio-fs. So there seems to be a bit of a gap, at least, between virtio-fs as a transport for Fuse and the dev Fuse character device. So if you were able to use virtio as a transport instead of the dev Fuse character device, you might be able to gain some performance. And this is specifically what Eugenio thought. And he was asking the question, can you use virtio transport on the same host, basically just for any normal Fuse file system to improve performance? And yes, you can use that, do that using vDPA and VDUSE to connect the virtio-fs driver you have on your host kernel to the emulated virtio-fs device that's running in user space. Again, for virtio-fsd, that's very boring, but for other Fuse drivers, it might be interesting. Now, I'm saying virtio-fsd is very boring, but it does contain a normal Fuse driver, right? So this normal Fuse driver could do anything that any other Fuse driver could do. So why don't we? The first very simple thing where we could start is to transform the file systems we present to the guest. So instead of basically just sending off everything as it comes, we could start simple and make things read-only, or we could transform metadata, like, for example, have a mapping of user IDs and group IDs that differ between host and guest, so that you can have different user IDs and group IDs for certain files in the host, on the host and in the guest. Or we can go better, we can do even better and go crazier. For example, we could integrate a network file system driver directly in virtio-fsd, that would directly connect to a network, and then virtio-fsd could serve this to a guest. The advantage is normally to connect virtio-fs to a network file system, you would mount it on the host, and then put virtio-fsd on top. By doing this, you save yourself that middleman, basically. You can do other things. You can have an archive file system driver, basically in virtio-fsd, so that you connect, so that you can have it open an archive file, and then serve its contents to the guest. Again, the question is why? Because the question is why, and the answer is because normally in this case, what you would do is maybe unpack it and then put virtio-fsd on top. But you see that this file system contains a lot of files owned by root, so unpacking it would require root privileges, and putting virtio-fsd on top also again would require to run this root, which we don't want. And also, we don't technically need, because it's just a normal archive file, right? So we can just have virtio-fsd open it like any other file and serve it to the guest. It doesn't require any privileges, so it shouldn't, right? Now, if I wanted to scam shareholders, which I don't, I would say that we can go even crazier, right? We could have a large language model that generates exactly the file system you want, exactly when you need it, and present it to the guest. So a completely virtual file system. But I don't want to scam shareholders, so I'm giving it back.
Okay, some of the things that we are working currently, that is baking it, so we already have some code upstream, is one is the read-only sharing. Basically, currently the only way to have like a real read-only sharing is to use a bind mount and then share that new mount to the guest. One of the words I really like is the ID mapped mount. The idea is currently that will be very useful for if you run containers inside of a VM. Currently there is some going on in the kernel to support this. So the idea is to have this. The ID mapped mounts, if someone is not familiar, it's like similar to username space, but only for file system. The idea is to do just mapping. Also, we are working to improve virtiofsd to be consumed as a library, as a crate library in Rust. So that could be integrated. Specifically, one of the main use cases is libcurrun, that currently is used by Podman. And also there is other people that wants to do that in Cloud Hypervisor and other projects upstream. Also, something that also will be very useful for containers is the ref-lib support. That the idea is when you copy one file in the same shared directory to a different place, it's not really a copy, it's a copy of write. So will be faster. And to make Jan happy, probably in the future we have IOMMU also, and we have more things in the to-do list in the future. So that's what we got. So thank you very much. And if you have any questions.
Thank you for the presentation. I have a question about the live migration. You mentioned that right now it's not so robust in some cases, like renaming a file or something like this happening during the live migration. What would happen actually if that if I were to use the currently released virtiofsd and this case happens? Is the live migration going to fail, or is there a risk of some data loss, or what would be the current behavior? And also, do you expect this to be fully fixed like in the next release, or is it something that will take more time?
Yes, that depends. We have some command lines that you can decide if you want the migration fails, but also we can only detect that in the target. Or you can just mark the say, okay, if the migration finds some error with some of the file that disappeared during the migration, the target, we can say, okay, let's not fail the migration, and just communicate to the guest when they try to access that file that file doesn't exist. It will be marked as invalid, like a bad FD or something. So currently you can choose. It's not, I mean, it will work, but the problem is there are a lot of corner cases that it can fail, especially if all these changes happens during the migration. It's happening before and after, there is no problem. With the file handle part, that will be pretty much solved, I will say. And yes, the idea is next release.
So one thing to say is that if we can detect this, we can mark it as an error. Because if a file is replaced, like we might not know. There are things to check it, like you can generate a file handle on the source and the destination, compare these two, and then can be relatively sure that if there is anything going wrong, you will have an error. But this only works if you have the same file system on source and destination.
Hi, thank you for the presentation. I'm curious about the secomp notifier. It's really nice way to, I never use it, to circumvent the privileges issues. How much latency did it add? Is it on the data path or control path?
Well, of course, that will be like a performance penalty. Since we are working and we have like we don't have like a fully working prototype yet. So I'm not sure exactly, because, for example, one of the things that didn't implemented yet is all the signature. So we expect that signing the file handle will take a lot of time, and probably will be the bottleneck of everything. So that we expect that the IIO path, the IIO operations will not be, let's say, penalized by this only when you open a file. So that will be the penalization, basically. But the idea is also to put cache and try to improve as much as we.
So just to expand on this idea, just thinking, like, I'm assuming that when you open the file, that all the requests, like, is it just one-time thing that during live migration you try to convert your file descriptors to file handles, or just open the file and every time it goes to this privileged component and you get the file handle back?
Well, we can do both, really.
Yeah, but in the current implementation, I'm assuming.
Yeah, well, from my side, I prefer to use file handles always.
Okay.
So it depends on what you're doing, right? You can, using file handles during migration does not have anything to do with whether you're using file handles during the normal operation. You can use either in any combination you want. Probably makes most sense to always use file handles during migration if you can. And then you only have this penalty during migration when you open it on the destination. You can still continue to use them for various reasons, and then you might have some penalty.
Yeah. Yeah. So it'll be Yeah, I don't know. I just wanted to raise this thought, but if it is feasible, if it makes sense, that just convert to file handlers only when you need live migration, because that seems to be the primary use case. But there are other benefits to file handlers, then doing it every time kind of makes sense.
You can configure it this way.
Yeah. No.
Yeah,
Oh, I can configure it this way already? Yeah. Okay, nice.
Well, you can already use file handlers, right, during normal operations, and you can disable that. And so if you disable that and only use it for live migration, then we'll all be converted to normal OPath FDs on destination, and you won't use any file handle during normal operation. So that part is already there, that we don't use file handles.
Thank you.
Thank you.